So in the previous lecture, we have seen about linear independence. So we will just recall that definition that f1, f2, fn are functions and c1, c2, cn are constants. And if you assume that c1, f1 plus c2, f2 plus cn, fn is equal to 0, that is, this is called as linear combination. So the linear combination is equal to 0, then you must be able to prove that C1 and C2 and Cn, all these constants are equal to 0. So this is how you show that the functions are linearly independent functions. So we have taken one example of saying that f1 is e raised to x and f2 is x. We have taken a linear combination here and assumed it 0, and then we have used the values of x. We have put x equal to 0 and then we have put x equal to 1, and we have derived that C1 and C2 must be 0. So this means that f1 and f2, that is e raised to x and x, are linearly independent. In similar way, we have also proved that sin x and cos x are also linearly independent on this given interval 0 to pi by 2. Means x can take values in the set 0 to pi by 2. Again, we have used the same logic. We have put x equal to 0 and then you have to put x equal to pi by 2, and you have got c1 and c2. So you may use any other technique also. You may put some different x and get two equations, and you solve those two equations, and then you get value of c1 and c2 is 0. Here also we have taken examples of x and x square linearly independent on 0, 1, 1 sin x and cos x linearly independent. This is also done in the class, and 1x and e raised to x are also linearly independent on the set of real numbers. Now what you must know that what is the meaning of linearly. What is it? How do you understand that if I give you two functions, what picture should come in front of your eyes? That what is the meaning of linearly independent? What is the meaning of linearly dependent? Means geometrically, what are you trying to tell? So suppose I take suppose let me take one simple example. Now you can start copying from here also. Suppose I'm taking x exercises. F1x is equal to x square and f2x is equal to minus x square. Okay, on for all x in real numbers. Okay, now what is now are these two functions linearly dependent or linearly independent? Is the set f1 f2 a linearly independent set? Right. So this means that now how would I now the thing is that if you observe clearly, you see that f2, which is minus x square, is nothing but minus of f1, because what is f1? Because f1 is x square, so this x square is nothing but f1. So this means that f2 is nothing but negative of f1. Correct? So I could find a relation between f1 and f2. What is the relation between f1 and f2? So this is the relation. This is the relation connecting whom? Connecting f1 and f2 both. So we could find a relation between f1 and f2. Okay. So if you can find a relation between which is connecting f1 and f2, means that if you see that the value of f2 म्हणजे f2 काय असायला पाहिजे? What should be f2? F2 should be negative of F1. This is what this relation is trying to tell us, right? So I'll repeat. What is this relation trying to tell us? This relation is trying to tell me that F2 should be how much? F2 should be negative of F1 means F2 is depending on F1. म्हणजे F2 हा F1 वरती डिपेंड होतोय. का? कारण F2 ची व्हॅल्यू किती असायला पाहिजे? F2 ची व्हॅल्यू शुड बी हाऊ मच? It is determined by F1. If F1 is 5, then F2 will be minus 5. So the value of F2 depends on the value of F1. This means that F1 and F2 are dependent on each other. Similarly, the same equation will tell you that F1 is minus F2. No, so what is the meaning of this? Means how much should be the value of F1? The value of F1 should be how much? It should be negative of the value of F2. Means F1 also depends on F2 and F2 also depends on F1. This means that F1 and F2 are what? Are linearly dependent on each other because one of them depends on the others. Here F2 depends on F1. If any one is dependent on the other person, I will say that that set is a linearly dependent set. So I not necessary to check that is F1 dependent on F2. So I could just find a relation between F2 and F1 that F2 depends on F1 in some case in this type. So I will say that here F2 depends on F1. Therefore, the set F1 and F2 is linearly dependent. Okay. Now a question will come in our mind that is this the way you have to show that the two functions are linearly dependent on or not? So this background I already knew that F2 becomes negative of what? F1. अपना original definition क्या है? What is the original definition of linearly independence? Take C1 F1 plus C2 F2 equal to 0 and try to show that C1 and C2 both are what? C1 and C2 uh, both are 0. Okay, so I will try that now. Okay, will I be successful? The answer is no because the set is linearly dependent. Okay, so let me write alternatively. Let C1 F1 plus C2 F2 be equal to 0. Now I will try to see, can I show that C1 and C2 are 0? Is there any problem if I try to do that? Suppose I show that C1 is 0 and C2 is 0, then it will mean that that set is linearly independent. So we know that this set is not linearly independent, it is linearly dependent. So ऐसा तो कभी होगा नहीं. So why? Let us see that. So therefore C1 F1 is x square plus C2 F2 is minus x square is equal to 0. So I'm getting C1 x square minus C2 x square is equal to 0. Now let me put some value of x. So put x equal to 0 डालने से तो कुछ नहीं होगा. If I put x equal to 0, what will happen? I will get 0 equal to 0. I will get nothing about C1 and C2. So if I put x equal to suppose 1, I will get C1 minus C2 is equal to 0. Now let me put some other x. Let me put to make one more equation. I have to put some other x. If I put x equal to minus 1 also, what will happen? Again, this equation star will become what? This star will become again C1 minus 1. Even if I put for x equal to minus 1, this will be minus 1 square. So again C1 minus C2 equal to 0 बन जाएगा. If I put x equal to, suppose if I put x equal to 2, then what will I get? Then I will get 4c1 minus 4c2 is equal to 0, which is, if I cancel the 4 out, I will again get what? C1 minus C2 0. So for every value of x, I am getting the same equation. I am getting what? C1 minus C2 equal to 0, C1 minus C2. I am not getting the different equation. I'm not able to find a different equation. This means I cannot find C1 C2. we cannot find C1 and C2. And see, I mean, we cannot find C1 and C2 means what? We cannot find fix. Let me write. We get that C1 and C2 need not be compulsory 0. So if you have an equation which is saying C1 minus C2 equal to 0, can you say that C1 and C2 both have to be 0? Can you say 100%? Can you say that hey यायला पाहिजे? You will say no, it can happen that C1 is 2 and C2 is also 2. So are you getting only this conclusion that C1 and C2 has to be 0? I'm getting a conclusion that I actually cannot determine from only one equation that C1 must be 0 and C2 must be 0. To show that C1 is 0 and C2 is 0, you will need one more equation. And if you do anything, you're not getting any other equation. You're stuck up in the same equation. Means you're not able to determine what is the value of C1 and C2. And not only that, you're not sure also that C1 and C2 must be 0. Okay. So we get C1 and C2 need not be compulsory equal to 0. Therefore, the set F1, F2 is what? Is therefore linearly dependent. अगर मैं prove कर सकता था that C1 and C2 has to be 0. Okay, you remember the definition. The definition says that if C1 F1 plus C2 F2 is 0, and then C1 and C2 must be 0. Okay, यहाँ पे क्या हो रहा है? C1 and C2 0 भी हो सकता है, C1 and C2 2 भी हो, 2 and 2 भी हो सकता है, 3, 3 भी हो सकता है. So C1 C2 3 भी चलेगा, 3 minus 3 is also 0. No, but the definition says that C1 and C2 must be equal to 0. That is not coming to be a conclusion over here. So this means that F1 and F2 means X and X square is a linearly dependent set. Okay. Let's take one more example now. I hope this is understood. Okay. Let us take an example now. Let F1x be equal to x square and F2x be equal to x mod x on the real line on R. Is the set F1, F2 linearly independent? Solution. Now I'm not telling you whether this set is a linearly dependent set or an independent set. Okay, so how will I just a minute. Okay. Yes. So now how will I do this? So let me start with my natural definition that suppose C1 F1 plus C2 F2 is 0, and I will try to see that can I get two equations, and from those two equations after solving can I get that the value of C1 and C2 is equal to 0. If I'm successful in that, this means that the two functions are linearly independent. Okay, now before that we will just quickly revise what is mod x. Now all of you know what is the definition of mod x. So when I put two dots here, it means I'm writing the definition. So I will just write the definition quickly here. You can also copy it. If the number is positive number, then mod x is replaced by. Okay, if I have number is already positive, so mod of 3 is 3. So if the number is positive, then the mod of x, this symbol, entire symbol, is replaced by only x. If x is 0, then mod of x is just replaced by what? Just replaced by 0, because mod of 0 is 0. But if x is negative, so if x is negative, then mod of that entire thing is just replaced by how much? By just 6. So मतलब ये जो x था, जो नेगेटिव x था, x कितना था? x माइनस 6 था. So उसका जब मैंने मॉड ले लिया, तो उसका आंसर मैंने कितना लिखा है? उसका मॉड लेने के बाद 6 लिखा है. मतलब x अगर नेगेटिव होगा, तो उसका मॉड्यूलस मैं क्या लिखूंगा? उसको माइनस लगा दूंगा. मतलब माइनस ऑफ -6 हो जाएगा. So वो ऑटोमेटिकली कितना हो जाएगा? +6. So this is how the definition of mod x works. Okay, so this definition we are going to use. If the number is positive, I'm going to keep mod x as x. If the number is negative, I'm going to replace mod x. I'm going to replace the entire mod x by what? I'm going to replace it by minus mod x. Okay, so now let us start the definition of linearly independent. So let C1 F1x plus C2 F2x be equal to 0. So therefore C1 into x square plus C2 into x mod x be equal to 0. This I'm calling equation star. Now I will put, obviously I will not put x equal to 0, because if I put x equal to 0, I will get 0 is equal to 0. So let me take x to be any positive number. Okay, so let x be equal to suppose 1. So what will I get? So if for positive number, what will happen? C1 into 1 square plus C2 into 1 into mod of 1 will be again 1. So this C2 will be equal to 0. So I'm getting one equation. And if I put x equal to -1, so what will I get? I will get C1 into -1 square will be again 1. So this is C1 plus C2 into -1 into mod of -1. So it is x into mod of x is equal to 0. So this is mod of -1 will become 1 and this -1 will remain. So I will get what? I will get C1 minus C2 is equal to 0, because mod of -1 is 1. So I got two equations, C1 plus C2 is 0 and C1 minus C2 is 0. Therefore C1 plus C2 is 0 and C1 minus C2 is also 0. I have two numbers in my mind जिनका addition भी 0 है और उनका subtraction भी 0 है. So this means that C1 is equal to 0 and therefore substituting I will get C2 is also equal to 0. This means that the set first function was x square and the second function was x mod x. This set is a linearly independent set on the set of real time. Okay, so I hope this exercise is now clearly understood. Okay, so we have taken the example of showing that x square and x mod x are both, these both functions are linearly independent functions. So we have proved that they are linearly independent. Okay, now always using this definition, it always this definition of using linearly independence and linearly dependence of C1 F1 C2 F2, this becomes lengthy. ह्याने कधी कधी काय होतं, खूप वेळ लागतो. So we must find out a shortcut of, can I show that the two functions are linearly independent by using some shortcut? Okay, so do I have to do all these calculations for all the things? It becomes slowly the task becomes difficult. So let me define something called as Wronskian. This W is silent. Wronskian. So I will take functions f1, f2, fn. I'm taking n functions on a set A B. Okay. Define Wronskian Wx Wx as follows. So Wx, now it's a big determinant. Wx is determinant so Wronskian Wx is the determinant. हा दिसायला खूप मोठा आहे कारण किती फंक्शन्स आहे त्याच्यामध्ये n फंक्शन्स आहे. आपल्याला आपण जेव्हा ऍक्च्युअल वर्कआउट करणार आहे तेव्हा 2 किंवा 3 फंक्शन्स घेणार आहे आपण. त्यामुळे हा डिटर्मिनंट आपला फार फार तर 2/2 किंवा 3/3 एवढाच होणार. सो इट विल नॉट बी व्हेरी बिग. ओके, सो जनरल मध्ये n/n डिटर्मिनंट जो आपल्याला कधी सॉल्व्ह करायची वेळ येणार नाहीये. सो व्हॉट इज द डेफिनेशन सेइंग? फर्स्ट रो यू टेक ऑल द फंक्शन्स. In the second row, you take the derivatives of the functions. So in the first row, zeroth derivative, okay? म्हणजे काहीच करायचं नाही. You have to keep the function as it is. In the second row, you take in the second row, the row is second, but the derivative is first derivative. So in the third row, you will get the second derivatives. And therefore in the nth row, the last row, this is the nth row. So you will get what order derivative? You will get n-1th derivative. So f1 n-1. Derivative is always written in a round bracket. Okay, after third derivative. Fourth derivative nantar, you write the fourth derivative like this. You don't start keeping like this 4 dashes. After third derivative, patience goes away. Okay, so this is the Wronskian of the functions f1, f2, fn. Okay, now when I'm writing, so I will now give you functions and I will ask you to find the Wronskian. You just are supposed to calculate the Wronskian. You are supposed to do nothing. But the question you must ask me is, sir, after we find the Wronskian, how will we identify whether these functions are linearly independent or not linearly independent? Okay, so the answer to that question is very easy. You find out the Wronskian, okay, and put any point in that Wronskian. Okay, the Wronskian find out करायचा, and in that Wronskian put any value of x equal to 1, x equal to 2, x, whatever easy value you want to put. And once you put that easy value in that Wronskian, if the answer of the Wronskian is not equal to 0, if it does not come out to be 0, then it means that the functions are linearly independent. Very easy trick to do this. So let me do one small example. We'll do it by using the method of Wronskian. Now all of you have understood that if I want to find the linearly independence of functions using the method of Wronskian, okay, not there in the earlier definition. If you look all of you carefully in this particular problem, okay, there is in this definition C1 F1 plus C2 F2. Here, when you were solving that, you were nowhere finding the derivative of the functions. You were just finding the values of you just substituted x equal to 1, x equal to minus 1, or x equal to 2, and you got equations. Then you solved those equations and you declared that the set is linearly independent. So if you want to go by the Wronskian method, what you should know is that you must be able to find the derivatives of the function. I hope everybody is expert enough to find the derivative of a given function, right? But I know that we are expert is fine, but what is the problem? That it may happen sometime that the functions that I have given you, you may not be able to find the derivative of the function, right? For example, suppose I ask you fx is equal to x mod x, जैसा वो ऊपर हमने लिया है, okay? X mod x. Now we know that if I want to find the derivative of x mod x, okay, what I do is x into derivative of mod x plus mod x into derivative of x. And here the problem comes, that do we know the definition of what is the derivative of mod x? So this particular Wronskian technique you will be able to use only if the functions have derivative. Sometimes it may happen that the functions do not have derivative. In that case, you will not be able to proceed by the Wronskian method. If in that case, how should we go then? Then अपना ओरिजिनल डेफिनेशन बैठा है C1 F1 plus C2, जहां पे डेरिवेटिव्स का जरूरत नहीं लगता. Note: to find Wronskian, one must be able to calculate derivatives of the given functions. Okay, so let's take an exercise now. Show that x square and x cube are linearly independent on R. Solution. So can I use the original definition of C1 x square plus C2 x cube equal to 0? Yes, you can use that definition also and try to show that what C1 and C2 both are equal to 0. You can also use that definition. Now we are using it by what? We are trying to do it by the Wronskian method. Okay, so what is the Wronskian? The Wronskian of x is equal to, we have two functions. This function is f1, this function is f2. So I have Wronskian is f1, f2, first line. Second line is the line of derivatives, f1 dash, f2 dash, which is equal to determinant of x square, x cube, then your derivative is 2x and your derivative is 3x square, which is equal to 3x raised to 4 minus 2x raised to 4, which is simply x raised to 4. Okay, so this is the Wronskian. Okay, can you find a point where the Wronskian is not 0? Okay, can you find the point where Wronskian is 0? Yes, that point is x equal to 0, but that is not important for me. What is important for me? Can you find a point where the Wronskian is not equal to 0? If you can find that point, then the functions are linearly independent. So let me write here. Okay, so can we find a point x naught, which is real number, such that Wronskian at that point is not equal to 0. Can you find that point? I will say yes. Just put x not equal to 1. If you put x not equal to 1, the Wronskian at 1 will be equal to 1 raised to 4, which is not equal to 0. Therefore, the two functions f1 and f2 are linearly independent on the set of all real numbers. So after writing this, now let us immediately, now I've given you an example, I've shown you by an example how to check the two functions are linearly independent. So let us write that definition of linearly independent functions. If f1 up to fn are differentiable functions, which functions I want? I want them to be differentiable functions which are solutions of some differential equation, which are solutions of some different, very important remark, okay? We will come to it, don't worry. This is right now not the point of focus, okay? We want to focus on the definite linear limit. So f1, f2, fn are functions which are solutions of some different. ये हम लोग बाद में देखेंगे. Then the set f1, f2, fn is said to be linearly independent if what? Wronskian of the functions which is wx, okay, जो हमने ऊपर define किया, it is determinant, that big determinant is not equal to 0 for whom it is not equal to 0 for at least 1x, not equal to 0 for at least 1 x naught in the domain. पिछले एग्जाम्पल में हमारा डोमेन कौन था? हमारा डोमेन R था. I will repeat. I will take functions f1, f2, fn which are differentiate, जिनको मैं differentiate कर सकता हूँ, और ये हम बाद में देखेंगे कि these functions must be solution of some differential equation. Okay, वो that we will look on in the next section. Okay, then this set will be said to be linearly independent if I will first calculate the Wronskian. Now Wronskian comes to be a function of x. Then I will start thinking, क्या डोमेन में मैं ऐसा एक बंदा ढूंढ सकता हूँ? Can I find a number जिसके लिए Wronskian 0 नहीं हो रहा? So I will say that at least एक तो आदमी मिलना चाहिए. Suppose you get that ऐसा एक भी बंदा नहीं मिल रहा जिससे Wronskian non-zero, then the set will become what? Then the set will become linearly dependent. लेकिन if you even you are successfully, if you are able to find one number x naught for which this Wronskian becomes non-zero, then the set will be a linearly independent set. Okay,